Now we're in chapter 5.5 and we're going to be dividing polynomials. Our first objective is to use the quotient rule for exponents. And the quotient rule says the following. If I have a base raised to a power, so b raised to the nth power, and I'm dividing by the same base raised to another power, so b raised to the nth power, the rule is to keep the base, so keep your b, and then subtract the exponents, and you'll have m minus n. So let's go in our books to page 387, and we're going to look at the following problems, starting with number 1. It says divide each expression using the quotient rule. Express any numerical answer in exponential form. And for number 1, we have 3 to the 20th power divided by 3 to the 5th power. So our base is 3, so we're going to keep our 3. And then our exponents are 20 and 5, and we're dividing, so we're going to subtract. So we're going to say 20 minus 5, which means we'll have 3 to the 15th power, and we'll leave it in this form. Let's look at number 3. We have x to the 6th power divided by x squared. Again, the base is x, so we're going to keep the x. And then we're going to subtract our exponent, so 6 minus 2. And we'll have x to the 4th power. And that's the final answer. For number 5, we have y to the 13th power divided by y to the 5th power. The base is y, so keep the y. And then subtract your exponent, so 13 minus 5. And your new exponent, or your new power, is going to be 8. So your answer is y to the 8th power. The number 7, we have 5 to the 6th power times 2 to the 8th power, all divided by 5 to the 3rd power times 2 to the 4th power. So this time we have multiple bases, so let's start with just the 5s. So we're just going to isolate only the 5s, so 5 to the 6th divided by 5 to the 3rd. The base is 5, so make sure you keep your 5. However, 6 minus 3 is 3, so this becomes 5 to the 3rd power. Avoid dividing your 5s into each other. Do not do this. Do not say 5 divided by 5 is 1, so you're going to say 1 to the 3rd power. Remember, the rule is to keep the base, so you have to make sure that you keep the 5, and it should be 5 to the 3rd power. Now we can look at our 2's. So 2 to the 8th power divided by 2 to the 4th. The base is 2, so keep the 2. And then 8 minus 4, that is 4. So our final answer is 5 to the 3rd power times 2 to the 4th power. And then number 9, we have x to the 100th power times y to the 50th divided by x to the 25th, y to the 10th. So just like number 7, we have to isolate our bases one at a time. So let's start with the x's. Our base is x, so make sure you keep your x. And then 100 minus 25 is 75. And then the next base are our y's. So make sure you keep the y. And then 50 minus 10 is 40. So the answer is x to the 75th power times y to the 40th power. Alright, objective 2 is the zero exponent rule. And it says the following. Any base raised to the 0th power is going to be equal to 1. So b is your base and is raised to the 0th power and is going to be 1. So again, any base to the 0th power is 1. Back in our books on page 387, let's start with number 11. It says use the zero exponent rule to simplify each expression. And we have 2 to the 0th power. Well, like we know, or like we just saw, anything to the 0th power is 1. So 2 to the 0th power is 1. Then number 13, we have negative 2 in parentheses to the 0th power. Now, since the negative 2 is all inside of your parentheses, it means that everything is raised to the 0th power. Therefore, anything raised to the 0th power is 1, regardless of how it looks on the inside. If it's raised to the 0th power, it is 1. Number 15, it says negative 2 to the 0th power. Well, this time we have to be careful because not the negative 2 is being raised to the 0th power, but only the 2. You see, look at the difference between number 13 and number 15. 13 had parentheses around everything, therefore I got a 1. In 15, the negative is not inside my parentheses, therefore only the 2 is raised to the 0th power. So 2 to the 0th power, this gives us positive 1, but the negative is still out front, so the answer is negative 1. Number 17, we have 100 times y to the 0th power. So again, let's figure out who's being raised to the 0th power. This time it's just the y. It's not the 100 as well. Therefore, y to the 0th power, well, we know that is 1. However, the 100 is still out front, so that's like saying 100 times 1, which is still 100. Number 19, so we have 100y, all inside parentheses, raised to the 0th power. So remember, anything raised to the 0th power is positive 1. So this time everything is inside parentheses and is raised to the 0th power, so this is going to come out to be positive 1. Okay, number 21. This time we have negative 5 raised to the 0th power plus negative 5 raised to the 0th power. Let's start with negative 5 to the 0th power. This time only the 5 is raised to the 0th power. So remember, 5 to the 0th power, well, that is 1, but the negative is still on the outside, so that's really negative 1. And then we have plus, and then this negative 5 to the 0th power, well, negative 5 is on the inside of my parentheses and is raised to the 0th power, so that is just positive 1. So then negative 5 plus 1 is 0. So the final answer is 0. And then number 23, we have negative pi raised to the 0th power minus negative pi raised to the 0th power. So remember, be careful on who's actually raised to the 0th power. In this case, it's just the pi, so the pi to the 0th power, that's 1, but the negative is still on the outside, so that's negative 1. And then we have minus, and then negative pi is on the inside of my parentheses and is raised to the 0th power, so this is just 1. So negative 1 minus 1 gives us negative 2. Our third objective is to use the quotients to power rule. And it says the following: if I have two bases, so a and b, so base a divided by base b, and is raised to a power, this is the nth power, the rule is to take each factor inside the parentheses and raise it to that power. So it's going to be a raised to the nth power, and then b raised to the nth power. So again, the rule is to take each factor and raise it to that power. Let's look at number 29. And it says simplify each expression using the quotients to power rule. If possible, evaluate exponential expressions. And for number 29, we have 2x to the third power divided by 5, all raised to the second power. So again, the rule is to take each factor and raise it to the power. So that means 2 raised to the second power, x to the third raised to the second power, and 5 raised to the second power. So 2 to the second times x to the third raised to the second divided by 5 raised to the second power. Now we need to simplify. 2 to the second, well, that is 4. X to the third raised to the second. Remember, when it's exponent to exponent or power to power, you multiply. So this is going to become x to the sixth power divided by 5 to the second, which is 25. Number 31, we have negative 4 divided by 3a to the third power, all raised to the third power. So again, each factor is going to be raised to the third power. That means negative 4 to the third power, 3 to the third power, and then a to the third power raised to the third power. So negative 4 raised to the third power, divided by 3 to the third power, and then a to the third power raised to the third power. Remember, power means take whatever being raised to the power and multiply it by itself that many times. So negative 4 to the third power is like saying negative 4 times negative 4 times negative 4, which gives us negative 64. And then 3 to the third power, that's 3 times 3 times 3, which is 27. And then remember, when it's power to power or exponent next to exponent, you multiply, so that gives us a to the 9th. So our final answer is negative 64 divided by 27a to the 9th power. And then number 35, we have x squared times y to the third power divided by 2z, and is all being raised to the fourth power. So remember, each factor can be raised to the fourth power, so that means x to the second raised to the fourth, y to the third raised to the fourth, 2 raised to the fourth, and z raised to the fourth. So x to the second raised to the fourth, y to the third raised to the fourth, over 2 to the fourth times z to the fourth. Now we simplify. Remember, power to power we multiply, so this will become x to the 8th power, y to the 12th, and then 2 to the 4th. Remember, that's 2 times itself 4 times, so it's 2 times 2 times 2 times 2, which is 16. And of course we still have the z to the 4th power. And here's the final answer. Next objective is dividing monomials. So when you're dividing monomials, there's 2 parts to it. The first part is to divide the coefficients. The coefficients are the numbers that are in front of your variables. Divide them. And then the second part is to divide the variables. Remember, when you divide the variables, you want to keep the variable and subtract the exponents. Keep the variable and subtract the exponents. So let's start with number 37. And we have 30x to the 10th power divided by 10x to the 5th power. So remember, the rule is to divide the coefficients together. Your coefficients are 30 and 10. So 30 divided by 10, well, that is 3. And then keep the variable, so keep x, and then subtract the exponents. 10 minus 5, which is 5. So this final answer is 3x to the 5th power. Number 43, we have 7y to the 17th power divided by 5y to the 5th power. So let's start by dividing our coefficients. Our coefficients are 7 and 5. We cannot divide them, therefore we're going to leave this as the fraction 7 over 5. And then for the variables, keep the y and subtract your exponent. 17 minus 5, well, that is 12. So the final answer is 7/5 times y to the 12th power. And then number 47. We have negative 18 x to the 14th power, y to the second, all divided by 36 x squared, y squared. So just like before, divide our coefficients into each other. So negative 18 divided by 36, that becomes negative 1/2. Make sure you leave it as a fraction, negative 1/2. And we're going to do our x's first, so keep the x, that's your base. Subtract the exponents. 14 minus 2 is 12. And then let's move down to the y. Keep the y. Subtract the exponents, but 2 minus 2 is 0. And remember, anything to the 0th power is just 1. So the final answer here is negative 1/2 times x to the 12th power. Remember, think of y squared canceling with y squared. No more y's, basically. And then number 49, we have 9 times x to the 20th power, y to the 20th power, divided by 7x to the 20th power, y to the 20th power. So again, let's divide our coefficients into each other. We cannot divide 9 into 7, so we're going to leave it as 9 over 7. And then x to the 20th divided by x to the 20th, well, these cancel each other out. And then y to the 20th divided by y to the 20th also cancel each other out. So the final answer is just 9 over 7. And then last one, number 51. We have negative 5, x to the 10th power, y to the 12th, and then z to the 6th power, all divided by 50, x to the 2nd power, y to the 3rd power, and then z to the 2nd power. So let's start by dividing the coefficients. Negative 5 divided by 50 is negative 1/10. And then keep the x, subtract your exponents. 10 minus 2 is 8. Keep the y's, subtract your exponent. 12 minus 3 is 9. And then keep the z, subtract your exponents. 6 minus 2 is 4. So the final answer is negative 1/10 times x to the 8th times y to the 9th and z to the 4th power. Last objective is dividing a polynomial by a monomial. So when you divide a polynomial by a monomial, you're going to divide each term of the polynomial by the monomial. So make sure you divide each term of the polynomial by the monomial. We're going to look at the last two problems, so number 73 and then number 77. For 73, we have 18 x to the 7th power minus 9x to the 6th power plus 20x to the 5th minus 10x to the 4th, all divided by negative 2x to the 4th power. So the polynomial is on top and the monomial is on the bottom, and we're going to divide each term of our polynomial by your monomial. So that means we have 18x to the 7th divided by negative 2x to the 4th minus 9x to the 6th divided by negative 2x to the 4th plus 20x to the 5th divided by negative 2x to the 4th and then minus 10x to the 4th divided by negative 2x to the 4th. So remember the rules for dividing monomials. Divide the coefficients into each other, keep the base, and subtract your exponents. So 18 divided by negative 2 is negative 9. Keep the x, and then 7 minus 4 is 3. And then negative times negative, well, that makes positive. And we cannot divide 9 by 2, so we're going to keep it as 9 over 2. Keep the x, and then 6 minus 4 is 2. And then keep going. 20 divided by negative 2 is negative 10. And then keep the x. 5 minus 4 is 1. And then negative and negative makes positive. And then, of course, 10 over 2 is 5. And remember, x to the 4th cancels out with x to the 4th. So here's the final answer. And then last one, number 77. We have 20x to the 7th power, y to the 4th power, minus 15x to the 3rd power, y to the 2nd, minus 10x to the 2nd, y, all divided by negative 5x squared, y. So again, divide each term of your polynomial by your monomial. So we're going to have 20x to the 7th, y to the 4th, divided by negative 5x to the 2nd, y, minus 15x to the 3rd, y to the 2nd, divided by negative 5x to the 2nd, y, and then minus 10x to the 2nd, y, over negative 5x to the second y. Now remember to divide your monomials, divide your coefficients into each other, keep the base, and subtract your exponents. So 20 divided by negative 5 is negative 4. Keep the x. 7 minus 2 is 5. And then y, remember there's an invisible 1 here. So 4 minus 1 is 3. So the first term becomes negative 4x to the fifth, y to the third. And then 15, negative 15 divided by negative 5 is positive 3. So plus 3. Remember, keep the x. And then 3 minus 2, well, that's 1. Keep the y. Don't forget the invisible 1. And 2 minus 1 is 1. And then negative 10 divided by negative 5 is plus 2. Remember, the x squares cancel each other out. The y's cancel each other out. And we're just left with negative 4x to the fifth, y to the third, plus 3xy, plus 2. Okay, this will conclude our video for 5.5. Please email me if you have any questions.